Right now, this very second, while you're sitting there as still as you know how, your head is getting older faster than your feet. Not in a manner of speaking, not as some lovely metaphor for growing up. I mean the actual clock of your body, the aging itself, is running a hair quicker up top than down at the floor, for no reason grander than that your head is a little higher off the ground than your toes are. And here's the part I have not been able to put down since you first said it to me. This isn't a riddle somebody dreamed up on a chalkboard. Somewhere tonight there is a person with two very good clocks, and they will carry one up a mountain and leave its twin down in the valley. And by morning the two will not agree, and it won't be the clocks that are wrong, it'll be time. So I've come down here with one question, and I want it answered slowly. How, in the name of everything sensible, does time run at two different speeds inside one ordinary body?
It does, though, and you've walked in with the whole night already sitting in your lap. Let me tell you where I want to carry that, because it's a strange little journey. Last time, you remember, we were out at the very edge of the imaginable. Two black holes, a billion years off, ending a long death spiral, and the shudder of that crash crossing all of that empty dark to stretch every one of us by less than the width of a speck inside an atom. Space-time, shaking. And it was so faint, so absurdly faint, that we spent the whole evening marveling anyone ever felt it at all.
I remember. I didn't sleep especially well after it, if I'm honest.
Well, here's the turn. You do not need the colliding black holes. You do not need the billion light years or the instrument tuned finer than anything humans have ever built. The exact same thing those waves were made of, space-time bending time, is happening in this room. To you, to me, to the chair you're sitting in. And I can show it to you with nothing grander than a clock and a flight of stairs.
A flight of stairs. That's the whole apparatus.
That's the whole apparatus. We've spent this entire course out among stars and holes and ripples, and tonight, I promise you, the laboratory is a staircase, and you're going to walk up it, and the top of you is going to live in slightly different time from the bottom of you, and I'm going to make you believe it before we're done.
All right, sell me the staircase. But I'll warn you, I climb stairs all day, and I have never once felt the top of me pull ahead of the bottom of me, so it can't be much.
It isn't. And I lean hard on that, because the amount is so small that your whole body, over your whole life, banks only the tiniest sliver of difference between crown and heel. Not enough to see, not enough to feel, not enough ever to notice with your own senses. But, and here's the thing that ought to trouble you worse than the black holes did, not zero, not nothing. A real, honest, measurable difference. And the only reason it's small is that the staircase is small, and the Earth, as gravity wells go, is a very gentle one.
So it's a real effect. It's just been considerate enough to stay too polite to bother me.
Too polite to bother you. That's it exactly. Loud enough to be true, quiet enough to ignore. Most of the time. But not always. Because it turns out this same polite little effect is loud enough that the machines you trust to tell you where you are on the Earth would be useless without it. But I'm running ahead. Let me do this properly and build it from a place you already own. Because you and I laid the foundation weeks back, and you've been standing on it ever since without once looking down.
Go on then. Where's the foundation buried?
Cast your mind right back to the rocket. Very early on, the accelerating rocket, the one we could not tell apart from standing on the Earth. We put a clock up at the ceiling and a clock down at the floor, and we let the whole thing race forward through empty space, faster and faster. And we sent a tick of light up from the floor to the ceiling. What arrived?
Something stretched, something slowed. The floor's ticks came in lazy and far apart, because by the time each pulse climbed up, the ceiling had gathered a bit more speed and was, in a way, running away from the message. So the ceiling clock ran faster than the floor clock. The top beat the bottom.
You've kept it beautifully. Clock up high runs fast. Clock down low runs slow. And then we did the wickedest thing in the whole course. We said, the box cannot tell the difference. A box accelerating through empty space and a box sitting still on the earth feel exactly the same to everyone inside. So whatever's true of the clocks in the rocket
Has to be true of the clocks in gravity. Exactly the same. So a clock higher up in gravity runs fast and a clock lower down runs slow. The ceiling of this room beats the floor. My head beats my feet.
There it is. You just built the whole of tonight out of a thing you already had in your pocket. Higher up, where gravity is that bit weaker, further from the Earth's pull, time runs faster. Deeper down, down at the floor, down in the valley, down where the pull is strong, time runs slower. And I want to nail that sign to the wall this instant, because it is the one thing people get backwards, and the moment it's backwards, nothing after it makes any sense at all.
Then let me say it back and you tell me I've got it. Stronger gravity. Down low, down deep, that's the slow place. Weaker gravity, up high, that's the fast place.
Deeper is slower. Higher is faster. Say it as a little tune and never let it go. The deeper you sink into a gravity well, the more sluggishly your time runs. The further you climb out of it, up toward where the pull thins away to nothing, the more briskly your time runs. The valley lags, the mountain races.
And there's something almost backwards about that, isn't there? My whole gut says the strong, heavy, pressing place, down at the bottom, where everything's being crushed toward the ground, that ought to be the busy one, the fast one. And instead, it's the slow one. The place with the most gravity has the least hurry.
The place with the most gravity has the least hurry. That's a lovely way to hold it. Keep it. And here's why the gut is worth trusting, even as we overturn it. Down in the deep, gravity is strong precisely because you're deep, close in to all that mass. And being deep in the well is the very condition that slows the clock. Weight and slowness are one fact wearing two faces. Where you feel heavy, your time drags. Where you'd feel light, up, out, away, your time flies.
All right, I've got the sign. Deeper slow, higher fast. But you keep saying measured, and that's the word I want to lean on. Because a clock on a mountaintop, running slow by some unimaginable sliver, how does anyone on Earth actually catch a thing that small?
For most of the history of this idea, nobody could. That's the part that ought to stop you. There was a long, long stretch where this was the wildest sort of prediction. A thing you could argue about over dinner, but never, ever touch. Time running at different rates a few floors apart. You could no more measure that than you could weigh a shadow. The differences were so fantastically tiny that the finest clocks of the age couldn't dream of catching them.
And now the clocks have caught up.
Now we have clocks so absurdly, so ludicrously fine that they would not gain or lose a single breath in the whole age of the universe. And with a clock like that, here is what you can do. You set two of them side by side, ticking as one, agreeing perfectly. Then you lift one. Just lift it, the height of a low table, the height of one single stair, the height of a stack of books. And the raised one begins, ever so gently, to pull ahead of the one you left below.
Across a stack of books.
Across the thickness of a book. Across the rise of one step. You can measure the bending of time on a staircase now. It's gone from a philosopher's fever dream to a thing a patient person shows you before breakfast, with two clocks and a step stool. That was the sentence I could hardly credit when I first met it. We read the shape of time off a staircase.
Would not lose a breath in the age of the universe. Say that one again, slowly, because I don't think it landed properly the first time.
I'll stand right behind it. Set one of these clocks ticking at the birth of everything, and leave it running, through all the ages of the world, down to this very night, and it would not have slipped so much as a single breath out of step. That is the fineness we're playing with. And here's the loveliest rough test anyone ever did with it. One you can nearly feel in your hands. Take a fine clock up into an aircraft. Fly it high for hours, all day if you like, up where the pull is that bit weaker. Then bring it home and lay it down beside the twin that never left the ground.
And the two don't agree.
The two do not agree. The one that flew comes home ahead. It's ticked away a sliver more of its life, up there in the thinner gravity, than the one that stayed on the tarmac. Not a story on a board, a clock you can hold in your hand, reading a time that's run on past its own twins, for no reason on this earth but that it spent the day a little higher up. They have done it, and it comes out the way the rocket promised, every single time.
Lift the clock the height of one step and it starts winning. Set it down and it, falls back level?
Falls back into step. Lift it again, it pulls ahead again. You can play the height of time like the slide on a trombone. Up, ahead. Down, level. Up, ahead. And every step you ever climb, you tip yourself a fraction further into the fast time country. The attic is ahead of the cellar, always has been. We simply couldn't read the gap until now.
I climb stairs all day, and it had genuinely never once occurred to me that I've been stepping between rates of time like stepping between rooms.
You've been doing it your whole life. Every time you stood up, you sped your head's clock a fraction over your feet's. Every time you climbed to bed, you spent the night a hair further into the future than the ground floor did. It changes nothing you'll ever notice, and it changes everything about what time even is. Because look what we've quietly done to it. We began this whole course with time as the backdrop, the stage, the thing ticking away in the wings, the same for everyone, while the interesting business happens out front.
The neutral referee, blind and fair, keeping one beat for the whole world at once.
And now look at the poor referee. It runs at different speeds in different places. Fast up here, slow down there. It sags where the gravity's strong and lifts where it's weak. That is not the behavior of a backdrop. That is the behavior of a landscape. Time isn't the stage the play happens on. Time is part of the scenery. It has hills of its own. It has valleys.
Time is terrain. I'm going to be chewing on that all night. But here comes the skeptic. You knew she was on her way. You keep telling me it's real, it's measured, it's honest, and I believe you about the clever clocks. But you dangled something a while back and then whisked it off the table. You said the little machines that tell me where I am would fall apart without this. That's the bit I can't let go of, because that's not a clock on a peak for a physicist to admire. That's the thing in my pocket that finds me a coffee.
That's the thing in your pocket. And this is where a rather austere little physics stops being austere and becomes the reason you got home last Tuesday. Tell me, the blue dot, the one on the map, the one that knows you're at this corner and not that one. How do you suppose it knows?
Honestly, I've always half assumed there's a satellite up there looking down and it sort of sees me, spots my little roof from orbit and drops a dot on it.
Nearly everyone assumes something like that, and it's wrong in the most wonderful way, because the truth is far stranger. Nothing up there sees you. Nothing up there is even looking. There's a small flock of satellites high, high above you, a whole constellation of them wheeling round the Earth, and every last one is doing exactly one thing, over and over, forever. It is shouting the time.
Shouting the time, that's the whole job.
That's the whole job. Each satellite carries a superb clock, and it broadcasts endlessly one single message. Here is the time. Here is the time. Here is exactly what time it is according to me. And your phone, down here, just sits and listens. It hears the shout from one satellite, and the shout from another, and another. And here's the trick, the whole trick. The shouts arrive a tiny bit out of step with each other.
because they've traveled different distances to reach me. The one more or less overhead gets to me sooner, the one off low near the horizon has further to come, so its shout lands a touch later.
A touch later, and your phone knows precisely how fast a shout travels. It travels at the speed of light, the one speed, the same for everyone, the very thing you and I broke our heads on a whole course ago. So from how far behind each shout arrives, your phone works out how far off each satellite must be. And once it knows its distance from several of them at once, several known points up in the sky, there's only one spot on the whole Earth it can possibly be standing.
This corner, not the other one.
This corner, not the other. It doesn't see you. It listens to a handful of clocks and triangulates you out of the lateness. Your position on the Earth is built, top to bottom, out of slivers of time.
So the whole machine is a timing trick. It isn't distance it measures, it's lateness. And it turns lateness into place.
It turns lateness into place. And now, feel how frighteningly sharp that timing has to be. Light is quick, monstrously quick. In the tiniest snip of a second you could name, a flash of light has already crossed a whole city. So if a satellite's clock is off, if it thinks it's a hair later or earlier than it truly is, your phone mistakes that clock error for a distance error, and the mistake is enormous.
Because a tiny wrongness in the time becomes a huge wrongness in the distance, at the speed light moves.
A stumble in the timing you could never perceive becomes a stumble on the map you absolutely could. Blur the clock by a whisker, and the dot jumps clean across the street. Blur it a bit more, and it jumps across the town.
Ah, and now I can see the trap you've been walking me toward all night. The satellites are up high.
The satellites are up high.
Up high, where you just made me say it myself, time runs faster. So the clocks up there are not keeping the same time as my clock down here. They're running fast, every one of them, the whole flock, gaining on me all day long.
There it is. You've caught the entire thing in a single breath. Those satellites ride far out of the Earth's well, up where the pull is thin, and their clocks run fast. Genuinely, measurably fast. Against every clock down here on the ground. Left alone, honest to their own fast time, they drift a little further out of step with us with every passing hour. And because the machine turns time into place, that drift doesn't stay a clock problem. It becomes a where am I problem. The dot wanders.
And it doesn't wander a polite little bit, does it? I can hear from your voice it doesn't.
It does not. Ignore this. Build the satellites, launch them, and simply forget that gravity bends time. And by the end of a single day, the blue dot would be off by the length of a long walk. Then further still, day on day, until the map is swearing you're somewhere you have never set foot, and the little voice is steering you, calmly, into a field.
In a day, not a decade, not some slow creep you'd catch at the next service. A day.
A day. The whole system would eat itself inside a day. Which means the people who build these things do not get to treat what we're discussing tonight as poetry. They can't nod at it politely and move on. They have to reach into the satellite before it ever leaves the ground and deliberately set its clock wrong. Nudge it, on purpose, off the time they actually want it to keep, so that once it's up there, up in the fast time country, the bending of time pulls it exactly into step with us down here.
They build the mistake in on purpose, so the sky can unbuild it.
They build general relativity into the hardware with their own hands. Einstein rides in every one of those satellites, whether the engineer ever spares him a thought or not.
So there's a man's ghost sitting up in orbit, quietly adjusting my clocks so that I can find a car park.
There's a man's idea sitting in orbit, and without it you could not find the car park, or the coast road, or your own front door much past lunchtime. And that's the thing I love most about tonight. Every other episode the effect was cosmic. You had to travel to a star, a hole, the far side of the universe to meet it. This one is in your hand. You have used gravitational time dilation today. You used it to get here.
All right, but hold on, slow down, because you glided past something and I felt it slip by. You said the satellites are up high, so gravity makes their clocks run fast. Fine, but they're not sitting still up there, are they? They're tearing around the Earth, whipping round and round. And back in the old course, the elastic universe, special relativity, you spent a whole night convincing me that a thing which moves fast has its clock run slow. So which is it? Up high, so fast, moving quick, so slow. Those two are pulling in opposite directions.
They are pulling in exactly opposite directions, and I could not have set that up better if I'd bribed you to ask it. This is the finest question of the night, so let me not rush it. You are entirely right. There are two separate effects riding on those satellites at once, and they point dead against each other.
Two effects, lay them out. One at a time, slowly.
The first is the one from the old course. The satellite is moving quickly, sweeping round the Earth, and plane motion slows a clock. We proved that a whole season ago. So on that count alone, the satellite's clock ought to run slow against yours on the ground. That's the special relativity effect, the motion effect. It drags the satellite's clock behind.
Right. Movement slows it. That's the twins, that's all of that machinery. And the second?
The second is the one we built tonight. The satellite is high, up out of the well where gravity is weak, and height speeds a clock up. That's the gravity effect. It pushes the satellite's clock ahead. So there they sit, the pair of them, on the same little machine. Motion trying to slow it, height trying to hurry it, quarrelling over one poor clock, one dragging back, one shoving forward.
So do they cancel? Please don't tell me they just cancel, because that would be an unbearably tidy ending, and I've learned not to trust you with tidy.
They do not cancel, and you're right not to trust me. They don't even match. One of them wins. And for these satellites, at the height they fly and the speed they go, it's the height that wins. The gravity effect is the larger of the two by a good, clear margin. The motion tries to slow the clock. The height speeds it up by more. Add the two together, let them fight it out, and what's left standing when the dust clears is a clock that runs fast.
So the honest bookkeeping is, motion says slow, height says fast, height wins, net fast. And it's that net fast the engineers have to reach up and correct.
That is the honest bookkeeping, top to bottom. And you've just done it in your own words. Both effects are real, both are measured, both are built into the machine. And when the sum settles, the clock runs fast, and someone has to answer for it before the thing ever leaves the launch pad.
There's something almost comic about it, though. This is supposed to be the deepest, strangest physics there is. Space-time, gravity, the shape of the universe. And its day job is stopping my phone from driving me into a lake.
And I'd say that's not comic at all. I'd say it's the most serious thing about it. A theory you can only meet at the lip of a black hole is a theory you take half on faith. But a theory that would be wrong by the width of a town every single day, in a device that 1 billion people carry in their pockets, that has to be corrected by hand, or it visibly, publicly, embarrassingly fails, that theory has nowhere left to hide. It's on the hook, every day, and it passes, every day.
Right, I'm thoroughly sold on the satellites, but let's come back down out of orbit, because you keep making promises about my own body, and I mean to collect. My head and my feet, the mountain and the valley. You said measured, not calculated, measured. Somebody's actually caught time running slow at the bottom of a staircase.
They've caught it across less than a staircase. I told you the clocks now are fine past all reason. This is what that buys. Two of them, side by side, agreeing to a fault. Lift one the height of a stack of books, and the raised one runs ahead. which means your head and your feet. When you stand, your head is the raised clock and your feet are the one left on the floor, and your head runs faster. Lie down, bring them level, and they very nearly agree again.
So my body's been keeping two slightly different times my whole life, and rearranging which parts of me are ahead every time I stand or sit or lie down.
Every time. And the mountain and the valley are only that same story, told with a bigger stare. Carry your clock up the mountainside, up out of the deep of the well, up where the pull is weaker, and it runs faster than the twin you left down in the valley. Bring it home, and it has truly ticked away a little more of its life than the one that stayed low. The climber comes back from the mountain a shade older than the sibling who never left the valley. The high country ages you faster.
Give me a sense of the size of it, though. My head over my feet, across a whole life. Are we talking a day, an hour, a minute?
Oh, nothing so grand as that. Across your whole life, stood tall the entire time, your head would run ahead of your feet by less than the flicker of an eyelid. A sliver so small you could never find it, never spend it, never feel it slip by. Try to save it up, and you'd have nothing at all you could hold in your hand.
So it's nothing. It rounds to nothing.
It rounds to nothing, and it is not nothing, and the whole of tonight lives in the gap between those two. Because this exact effect, this same bending of time, is not always a flicker of an eyelid. Make the gravity strong enough, a star, a black hole, and the flicker swells to years, to centuries, to forever, right at the lip of the hole, the way we watched a fortnight ago. It's the very same effect. The earth simply serves it to you in the smallest spoon there is.
The mountain ages you faster than the valley. That is precisely upside down from how it feels. The valley's where you slog through your grey days. The mountain's where you go to feel like time has stopped and the air's clean and nothing's chasing you. And it turns out the mountain's the one quietly winding your clock forward.
The mountain winds you forward. The still, timeless feeling peak is the fast place, and the busy, heavy valley is the slow one, because the valley sits deeper in the earth's well. Feeling and fact, dead opposite, one more time. And I want you to sit in that a moment, because it's easy to hear a tiny sliver and file the whole business under harmless. It is harmless. It is also the ground opening under your feet.
Go on, open the ground.
Two people, same parents say, born the same hour. One lives their life high, a mountain town, a top floor, a life spent up. One lives their life low, a valley, a cellar, a life spent down. When they are old, they will not have lived the same amount of time. The high one banks more, fewer hours for the low one, more for the high, and no clock anywhere, no authority, no referee in the sky can say which of them kept the real time. Because they both did. There isn't a real one to appeal to. There are just the two, honestly different.
And that's the part that gets me, right there. Not that the numbers come out different, that there's no true one behind them. I keep wanting to ask which clock is right, and you keep, very gently, refusing to let the question exist.
Because it's the wrong question, and letting it die is the whole lesson. There is no master clock. There never was. We invented one, in our heads. One great tick behind the universe that everything else keeps time against. And it was a comfort, and it simply isn't there. What's there instead is a clock for every path. Every route through the world carries its own time and logs its own hours, and they don't have to match, and not one of them is the true one. That's the thing we keep reaching for, the great clock on the wall of the world, the one everyone could set their own watch by. And I have to tell you, as gently as I can, that we've searched the whole wall and there is no clock hanging on it. There's only every traveller and the watch on every wrist, each keeping perfect time along its own road, each one honest, each one right, and not a single one of them the one true noon that all the others answer to. The valley keeps its time, the mountain keeps its own, and the universe never once appointed a referee to say which of the two is really telling you what o'clock it is.
A clock for every path. Hang on, that's the twins again, isn't it? From the old course.
That is the twins again. I wondered when you'd smell them. Tell me the shape of it. You always told it crosser than I do.
Oh, I was furious about the twins. I remember it perfectly. Two sisters, one climbs into a rocket and roars off across space, out to some far thing and back, going fantastically fast the whole way. The other stays home, feet up, kettle on. And when the traveller comes home, this was the outrage, she's younger. Actually younger than the sister who stayed. Less life gone by for her because she was moving, and moving slows the clock, and she came back having ticked away fewer years. The stay-at-home's gone grey and the traveller's barely aged a day. And I thought it was a swindle.
Why a swindle? Say why it smelled off to you.
Because you can see it. If it's all about who's moving, then who's moving? From the traveller's own seat, she's sitting perfectly still, and it's the Earth and the sister and the whole world that went roaring off and roaring back. So why doesn't it come out the other way round? Why isn't the stay-at-home the young one? It felt like the universe just choosing a favourite for no reason. Motion's meant to be relative. That was your whole opening sermon. So how does motion alone get to decide which sister keeps her years?
Hold that thought just as you've built it, because the whole puzzle is a trap laid on exactly that symmetry. From the sister's own seat, she sits still, and the world goes rushing off and rushing back. From the world's seat, she does the rushing, and the world sits still. A perfect mirror. And if that mirror were the whole of it, the two would have to come home the same age, and there'd be no younger sister to argue about at all.
Which is precisely why I smelled a rat. The picture looks symmetric, but the answer plainly isn't. One of them really does come back young. So, somewhere, somebody's cheating, and I could never once find where.
And that is the sharp, honest, correct objection. And tonight is the night I finally get to answer it properly. Because tonight you're holding the piece that was missing back then. It was never motion alone that decided it. Let me put the two sisters back on their paths and ask a different question. Not who moved, a plainer one. Each sister travels from one meeting to the next. They part, and later they reunite. Two events, a goodbye and a hello again, and between them, each sister takes a route through space-time. And along her own route, each sister's own clock logs her own hours, the time she personally, bodily lived. Now, the two routes are different, so the two logged times can be different, and the question that actually matters is not who felt like they were moving.
It's whose route racked up more hours.
Whose route through space-time was longer aged. Which path banks the most lived time. And that has a real answer, one both sisters agree on completely.
Longer aged. You're putting the time onto the path itself, not the speed, the route, the road each one took.
The road carries the time. This is the idea I've been walking you toward all season, and here it finally has to stand up straight. It has the plainest name. It's just the time. Your time. The hours your own clock reads as you travel your own road from one event to the next. The time you actually live through. And the deep fact, the one that reorganizes everything, is that this lived time is not the same for two different roads between the same two events. It depends on the road you took. It's a property of the road.
So when I ask how much time passed, the real answer isn't a number the universe hands down from on high. I have to ask each road separately.
Ask each road separately. And now let me give you the single most surprising thing in the whole of it, the thing that turns the twins from a swindle into a law. On an ordinary map, on the ground, you know what a straight line is. It's the short way. String pulled tight between two towns. Least distance, straightest, shortest road. And every wiggle and detour only makes it longer, yes?
Of course, straight is short. Every child knows it. The straight road's the mean road, the thrifty road, the shortest one there is.
In space-time, it is upside down. The straight path between two events, the free, unforced, coasting path, is not the shortest in time. It is the longest. It banks the most hours. And every wiggle, every push, every turn, every burn of a rocket, every least departure from just coasting, costs you time, takes hours off.
Wait, so it's the reverse of the map. On the ground, straight is the short way, the cheap way. In time, straight is the long way, the most lived way. And the wiggles don't add time, they spend it.
The wiggles spend it. And that one flip hands you the whole resolution of the twins, clean. Which sister coasted? Which one took the straight, free, unforced road through space-time? Did nothing, just glided from the parting to the reunion.
The stay-at-home, the one with the kettle. She didn't do a thing. She just carried on, sat still, let time run.
She took the straight road, so she banks the most hours. She ages the most. And the traveller?
The traveller had to turn around. That's the asymmetry. That's the thing I couldn't find before. She fires the rocket to go, she fires it again to stop and come home. She wrenches her whole path around out there at the far end. She's the one putting bends in the road. So her road's the bent one, and the bent one's the short-lived one, and she comes back young. Not because motion picked her, because her route through space-time was the shorter-aged one. And it was shorter-aged because she's the one who bent it. She's the one who felt the turn.
You've solved it. You've genuinely solved it. The thing that had you crying swindle a whole course ago, you've just taken apart with your own two hands, and the tool you used was tonight's tool. It's not who moved. Motion by itself is relative, exactly as I told you back then, and you were right to hold me to it. It's whose path through space-time was longer aged, and that has a real, honest answer both sisters agree on, because bending your own path is a thing you can feel. The traveller felt every turn, the pressure of the rockets in her back. The stay-at-home never felt a thing.
The one who felt nothing took the straight road. The one who felt the turns took the bent one. And straight ages you most.
Done. That's the whole of it. But now, watch, because I didn't call the twins back on stage just to settle an old debt. I called them back because they've got everything to do with your staircase.
I could feel that coming. Say how. Because from where I'm sitting, motion and gravity look like completely different animals. One's about rushing around, the other's about how high up you happen to be.
They look different, and underneath they are the same one thing. And the same one thing is the one we just named. Your lived time, the hours your own clock banks along your own road. That is the single real quantity in all of it. Motion changes it. Height changes it. But there aren't two separate rules. A motion slows clocks rule filed in one drawer, and a gravity slows clocks rule filed in another. There's one rule. Every road through space-time has a length, measured in lived hours, and the shape of space-time sets that length. Move fast, and you've chosen one kind of road, and it banks fewer hours. Sit deep in a well, and you've chosen another kind of road, and it also banks fewer hours.
Two different ways of drawing a shorter-aged road through the same landscape.
Two different ways of drawing a shorter road. The slowing was never two effects. It's one accountant keeping one ledger, the ledger of lived time, and motion and gravity are just two entries in it.
So the twins and the mountain are the same story. In the twins, the traveller loses hours by bending her road with speed. On the mountain, no, wait, let me get this the right way round. You warned me it flips easily. On the mountain, the valley sister loses hours by sitting deep in the well.
The valley sister loses hours by sitting deep. Same ledger, different entry. In the twins, the road bent by motion is the short-lived one. In the well, the deep road is the short-lived one. Both are just space-time measuring the length of a path in the only currency it deals in, time actually lived. And once you see that, tonight's two dazzling facts collapse into one plain sentence, and it's the sentence I want you carrying up the stairs. There is only ever one thing going on. Every road through space-time has a length in lived hours, and everything, motion and gravity and twins and mountains and satellites, the whole lot is just the counting of that length.
One accountant, one ledger, motion and gravity, two ways of writing in it. That's actually simpler than the two separate mysteries I walked in with. You've taken two strange things and handed me back one.
One strange thing, and it's the true one. But I've saved the best of it for the very last because it does something you won't have seen coming. It reaches all the way back and grabs the first night of this entire course. It tells you, at long last, what falling is.
Falling, all the way back to the beginning. Go on then.
We opened this whole course with the man who lets go, the happiest thought, weightless, falling free, feeling no gravity at all. And a few weeks in, we learned that a freely falling thing is following a geodesic, the straightest possible path through curved space-time. The Great Circle Road, the taut string road, going as straight as the landscape will let it, with no force pushing it. Just going straight. You remember?
The straightest path. Free fall is going straight through a bent world. The planet orbits because it's going as straight as it possibly can. I've got it. It was the loveliest turn in the whole course.
Now lay the two ideas side by side. Tonight's and that one. The straightest path through space-time is the geodesic. And tonight we found that the straightest path through space-time is also the longest aged one, the road that banks the most lived hours. So the geodesic and the longest aged road are the very same road.
Which means the freely falling path, the path of the thing that just lets go,
is the path that ages the most. Of all the ways a thing could get from here and now to there and later, the one it takes when you simply release it, the falling one, is the one that racks up the most time.
So the falling thing isn't being dragged anywhere at all. It's seeking. It's finding the road with the most hours in it.
It's finding the road with the most hours in it. That is what falling is. Not a thing hauled down by a force. A thing sliding along the grain of time toward the road that lets it live the most. Drop an apple, and it isn't yanked to the floor. It's coasting along the longest aged route between the instant you let go and the instant it lands. And that route happens to bend toward the ground. The falling you have felt your whole life, in your stomach, on every step you ever missed. That isn't a pull. That's you, briefly, taking the straightest, longest aged road through the shape of time. The road you're always on the very edge of and almost never let to follow, because the floor keeps getting in the way and shoving you off it.
Then let me ask the thing that's been nagging me since the satellites. A ball I throw, it goes up in that lovely arc and comes back down. Why that arc? Why not straight up and straight down? Or some other shape entirely?
Because that arc is the ball hunting for the most time it can get. Watch, it faces the very same quarrel your satellite faced. Up high, the clocks run fast, so the ball would dearly love to climb, to spend its journey up in the quick-time country, banking hours. But climbing means moving, and moving slows its clock, and that costs it hours. So it can't just rocket straight up as hard as it pleases. The speed would eat the height it bought. And it can't loaf along low the whole way either, or it never reaches the fast country at all.
So it splits the difference, up enough to catch the fast time, but not so fast that the moving spoils it.
It splits the difference to perfection. That gentle arc, the curve of every thrown thing you have ever watched fly, is the one path that banks the most lived time between your hand and the ground, the exact truce between height and speed. The ball isn't tracing a curve because a force is bending it. It's coasting along its own longest-aged road, and that road, drawn out in the air, happens to be an arch. The very same two effects that quarrel over a satellite's clock, high over your head, quietly settle the shape of a stone you toss to a child.
The floor shoves me off it. The ground under my feet, that's the thing bending my road. That's why I feel heavy. I'm being held off the falling road.
You are being held off the falling road every second you stand still. The ground pushes up on your soles. You can feel it this instant, the chair on you, the floor on your feet. And that push is bending you away from the free, straight, longest-aged road you take the moment you let go. The falling person, the weightless one, is the one on the straight road. You, sitting there feeling your own weight, are the one being forced off it.
So the two sisters and the falling apple are the same sentence. The sister who coasted banked the most hours. The apple that falls banks the most hours. Both of them just let go and took the straight road, and the straight road is the one with the most life in it.
The very same sentence. Let go and you take the straight road, and the straight road is the longest aged. Hold on, stand on the ground, fire the rocket, climb the stairs, and you bend the road, and you bank fewer hours. It's one law, and it's been the same law since the first night, when a man stepped off a height and felt his gravity vanish. He wasn't escaping gravity. He was, for 1 second, on the longest-aged road there is.
I need to just hold that for a second, because it turns the whole thing inside out. I've spent my life thinking of falling as the thing that happens when you fail to hold on, when you lose your grip. And you're telling me falling is the natural state, the straight road, the free road, the one with the most time in it. And it's the holding on that's the effort, the standing still that's the strain against the grain.
The standing still is the strain. Holding on is the work. Falling is what space-time does the moment you finally stop fighting it. And you felt that, haven't you? There's a peace in it, a rightness, we've all felt and never had the words for. The drop of a swing at the top of its arc, the moment the wheels leave the road over a hill. That little lift in you isn't fear, not only. It's the body recognizing, for half a second, that it's back on its true road, the one it was always meant to travel, the longest-aged one.
You've just made me homesick for falling. I don't know whether to thank you or send you a bill.
Send me the bill. I've earned it, and it's the last one I'll charge tonight, because we've arrived at the thing this whole course was built to hand you. Time is terrain, not the backdrop, not the neutral tick behind the play. It has hills and valleys, fast country and slow, and everything with mass rolls along its longest-aged roads. And we call that rolling gravity, and we call that road falling. And there was never a force in a single bit of it. Only the shape of time, and things going straight through it.
And the satellites are up in the fast country, banking hours quicker than us. My head's in slightly faster country than my feet. The mountains faster than the valley. And the falling apples on the straightest road of all. And it's all one thing. It's all the shape of time.
It's all the shape of time. And that, hold on, because here's where the floor tilts under us one last time tonight. That is exactly why I can't send you up the stairs comfortable. Because we have this thing now, this one object, this shape. The local ruler and clock we built weeks ago, the thing that bends time steeply near a heavy Earth and gently up in orbit. It is not a special trick for satellites. It's not a party piece for mountaintops. It's the thing that governs every clock and every falling stone and every orbit, everywhere, always. It is completely general.
Completely general, meaning it doesn't only work near an Earth. or near a star.
Meaning it works on anything with weight in it. Anything with mass, energy, the stuff that bends time. And I've watched your face do the arithmetic all season, so let me just ask you the question I can see you circling. If this one shape governs the time near the Earth, and the time near a star, and the time near a black hole, what governs the time near everything? All of it at once? What happens if you don't feed the equation one star, or one Earth, but the whole thing? Every galaxy, every last scrap of matter there is, the entire contents of the universe poured in on one side, all together.
You take the same equation, the one bending my phone's clocks, and you don't hand it a planet, you hand it the cosmos, everything, and it hands you back the shape of time for the whole universe.
The shape of time and space for the whole universe. One solution, everything on one side, and the geometry of all of it on the other. And here's the thing I'll leave hanging over your head the whole climb. The thing that stopped the man who first tried it dead in his tracks and would not let him sleep. When you actually do it, feed the whole cosmos in and turn the handle, the equation does not hand you back a universe sitting still. It cannot. The mathematics simply will not permit a universe that holds its shape, that stays put, that rests. Feed it everything, and it tells you, flatly, that the everything has to be moving, that space itself cannot sit still.
Space itself can't sit still, not the things in it. Space.
Space. The stage. The terrain. The very fabric we've spent 10 nights learning to bend. The equation says it has to be on the move, all of it, everywhere, and it will not sit down no matter how sweetly you ask. And the man who found that lurking in the equation didn't believe it. He was certain he'd made a mistake. He reached in and pinned the universe still with his own hands, forced it to hold its shape because a moving universe was simply too much to swallow. And that reaching in, that pinning, turned out to be the greatest blunder of his life. Because the universe really was moving, and his own equation had told him so before a single soul thought to look up and check.
So that's where you're sending me, not up a mountain this time.
Not up a mountain, up to the whole sky. Next time, we feed the entire universe into the same equation that nudges your satellite's clock. And we find out why it will not, cannot, hold still.
Then I'll carry that one up the stairs too, my head running a hair ahead of my feet the whole climb, apparently, into its own little future. I came down tonight certain that time was the one thing that held still while everything else moved, the steady floor under all of it. And I'm going back up having learned it's the most restless thing there is. It runs slow in the valley and quick on the peak. It bends every falling apple. It rides in the satellites over my head, and someone has to reach up and correct it before breakfast, or I'd lose my own front door by lunch. And now you tell me the whole of it, all of space, everywhere at once, can't even sit down. So I'll go up slowly, one step at a time, one little future per step, and I'll be back down early to find out what a universe does when its own equations won't let it rest. Good night.